Welcome to the YouTube channel named as CAT OMETs by Manoj Mahajan. We've already started the QA Mind Boggling Concept Series, where we are going to look forward to cover up 200 plus concepts relevant for CAT and OMETs. So make sure that you do watch the video till the end so that you get to know the mind boggling solution for this particular problem. So let's first have a look of the problem out here. There are 200 boys in a hostel. 56% of the boys drink beer, 48% of the boys drink vodka, and 42% of the boys drink rum. What is further given is if 62% of the boys drink at least two drinks, then what can be the maximum number of boys who drink all three? So it's a set theory question, no doubt, but we are going to solve with the magical monkey method. So triple M method, which I call actually. So you would be surprised and shocked also to know this method. It's a completely logical problem. Let's see how we're going to apply. So over here, there are 200 boys. In this problem, for me, I'm going to consider them as 200 monkeys. So sounds interesting. So it's magical monkey method. Now what is given further over here is in percentage some data is given and the problem talks about what can be the maximum number of boys who drink all three. So we can solve this problem in percentage term also and then finally convert the answer into the number. Or what we can do is we can convert initially into numbers so that we get the direct answer also. So 56% of 200, if I calculate, would be nothing but equivalent to 112. Now it's a magical monkey method where I'm going to distribute toffees. So I'm assuming there are 112 toffees of the same type. Let me name that as capital B over here. Let's calculate 48% of 200, which would be nothing but 96. So 96, if I look over here, another kind of toffee we have, and we can name that with the capital letter V over here. So B, V. Next, if I move 42%, that is equivalent to 84 if I look over here, and the another kind of toffee which I am writing with the letter R over here. Now just remember the constraints. If you want to make it a set theory problem, please understand that this 56% of the boys equivalent to 112 are unique in number. What I mean by that is whatever common we are going to do would be between this figure, and this figure. So what I'm trying to say, when you start distributing the 112 toffees of B type, you have to give to every monkey exactly one. So remember that the same type of toffee, you cannot give more than one. Either you're going to give that type of toffee to a monkey or you're going to not give to a monkey if you're not liking the monkey. So that's interesting problem way we are looking at. So which means 112 would be given to 112 different monkeys. 96 will also be given to different monkeys and 84 will also be given to different monkeys. Now the overlapping can happen. So the maximum which you can give to any monkey if you like the monkey would be 3 in number, which means 1 from B, 1 from V and 1 from R. And it is not compulsory that every monkey should get at least one toffee. So you can leave some monkeys with 0 toffee as well. So we have to make them stand in a line 1, 2 and so on till 200. And let's see how we are going to distribute. So another constraint, remember that you have to distribute all the toffees. You won't be keeping the toffee with you. You have to distribute all the toffees out here. So we have over here the problem that 62% of the boys drink at least 2 drinks, which means if you convert 62% of 200, which would be nothing but 124. So 124 monkeys we have to ensure which have at least two types of toffee. So we have to see how we are going to distribute now. So when we are going to start distributing, we have to look at total toffees also out here. Let's calculate that. So what do I have is over here. If I add this nothing but 2, 1 carry forward, 9 and 1, 10, 1, 11 and 8, 19. So 9 over here and 292 toffees we have. So what we can look forward is, of course, we have to look 124 monkeys which have at least two type of toffee. So we have to give two toffees to each of the monkey. Let's say if I start from 1. Of course, these two toffees would be of different type that we have to ensure. So when we start distributing till 124, so 124 into 2 if I do, that is how much? 248. So 248 toffees we have to distribute, and total we have is 292. So let me subtract 248 from here. So what is the number we are going to get over here left out is 44 toffees. Of course, every monkey would be getting two toffees till 124 for sure. And what we are looking is different type of toffee also. So if I look over here, we can distribute the different toffees to each of these monkeys. Now this remaining 44 will depend on what kind of problem we have, right? So we have to find out the maximum number of boys who drink all three. So when you have to put all three out here, maximum, so of course you're going to distribute to those monkeys which already have two different type of toffee. So what we can do is, we can start distributing one more toffee to each of the monkeys. Until 44, we can actually look forward to give the monkeys three different kind of toffee. So if you look this data also, we have to ensure that yes, we can definitely give to 44 monkeys three different kind of toffees out here. And of course, from 45 till 124, again, we have to ensure that we can look forward to give two different kind of toffees. So which is very much possible out here if I look at the problem. So I'll show you also how you can look forward to distribute different kind of toffees. But this is the easiest way to solve this problem. So we got 44 monkeys having three type of toffee. So that could be the maximum which we can look forward to do so. So the question is theta. So the correct answer is 44. If the question would have been, let's say, minimum instead of maximum. So minimum number of boys who drink all three. So what we could have done is that this 44 toffees, if I look over here, we could have started distributing from 125 onwards rather than giving on the number 1 to 124. We can look forward to distribute over here. So from 125 till 168, we can look forward to give the toffee. So in this case, you can see over here that the minimum number of boys who drink all three, and over here if I see the minimum number of monkeys who have all three toffees is nothing but 0. So the maximum would have been 44 answer, which is the question also. And if I wanted to answer minimum, that answer would have been what? 0. And let me show you quickly out here that how we could have distributed a different kind of toffees. So that's something you need to always figure out while answering the problem also. So what we could have done is, let's say from 1 to 112, we could have given, let's say, B kind of toffee. So we want 112 monkeys having these toffee. Now till 124, you have to reach out. So what we can look forward to do over here is from 113, let's say, I can start distributing the V kind of toffee. So let me show you that 12 toffees, if I give it like this till 124, how many left out if I look over here from 96, if I do, that is nothing but equivalent to 84. So this 84, I can look forward to distribute on this portion. So that again, I'm ensuring that every monkey get two different kind of toffees. So that's what we could have done. And now from 84 till 124, how many, if I look over here, 40 more. 40 more we could have given from R. So let me distribute 40 from here. So left out is what? 44 R is left out. So we could have given, let's say, from 84 onwards, if I start counting. So I could have given till where? 124. So you can see that the 124 monkeys have two different kind of toffees. So you don't have to do like this. I'm just showing you that you can distribute. So that check you have to, of course, do in the problem. The way I have solved, you could have looked like this. And now if I look over here from 125 till 168, I could have distributed this 44, which is left out, right? So let me start distributing out here. So till 168, we could have given like this. And from 169 till 200, we are not being able to give any toffee to the monkey, right? So over here, you can see this would have been done if we have to find out the minimum number of boys who drink all three. If the problem would have been, as in the question also, maximizing, in that case, we could have distributed on this part 1 to 84. So you know that 1 to 44, we could have given what? R. So 44 would have become the maximum what we could have given the three kind of toffees to the monkeys. And that is your answer. So you must have really loved the method which I have discussed over here. So make sure that you do subscribe to my channel CAT OMETs by Manoj Mahajan so that you can look forward to cover up 200 plus concepts, and you would be surely surprised with the way I'm solving the questions out here. Already on the channel, I've uploaded two videos. This is the third concept. Soon we are going to come up with the other concepts as well. So make sure that you do share the video with the other CAT and OMET aspirants, and also do like the video and ask people to subscribe to the channel. So we are providing the free videos on the channel. So definitely it would be very much beneficial to you the way I'm looking at the problems out here. So definitely such ways are going to make your life easier. And probably if I look from the exam perspective, you would be able to solve much faster with ease. Thank you so much.